Draw here a vertical line because it is given that the base of the pentagon is perpendicular to XY line, and this length is 30 mm because the base side of the pentagon is given as 30 mm, and from this draw a pentagon like this. So this pentagon represents the top view of given pentagonal pyramid. Now after this top view, drawing this top view, let me name the endpoints point A, point B, point C, D and E, and find out its axis. To find out the axis of this solid, we have to join the points of this corner to the midpoint of the opposite line segment, means midpoint of BC and E. Similarly, midpoint of AB and D to be joined, and both these lines will intersect at one point, and this point is the midpoint of this pentagon or CG of this pentagon. So from that center of gravity, draw a center line, and this center line represents the axis of this pentagonal pyramid. Now after locating the axis of this pentagonal pyramid, height is given to us, that is 50 mm. So from XY line, mark a point at a height of 50 mm on this axis like this, and insert this dimension like this, 50 at the middle. Here aligned system of dimensioning is employed, and this line, this point represents the apex point of this pyramid. Hence, as it is a pyramid, join this point with triangles. So for that, draw vertical lines from point A and B, that will, and find out one point over here. Vertical lines from C and E, one point is here, and vertical line from D, another point is here. So these points A, B, C, E and D are the front view of this top view point. So this point is A dash and B dash, this point is C dash and E dash, and this point is D dash. Now join these points with apex point. So mention the name of the apex point like this, and join with a triangle as shown over here. So these apex points is joined with this point and this point with the slant edges. Similarly, this edge apex point to C, OC, is shown over here because it would be visible because it is here, and OC will not be visible, and here overlapping of visible line and invisible line is there. So we have to draw a visible line over here. Dotted line is hidden behind this full line. Apex point O, this is A dash B dash, here C dash E dash, and this is point D dash. Name these points like this, and this is apex point O dash. Now in top view, join O with A, O with B, O with C, O with D and O with E. This represents the slant edges which joins the base points A, B, C, D, E to an apex point O. So these slant edges are to be shown in top view like this. So until now we have drawn the first line of given problem. A pentagonal pyramid, 30 mm base side and 50 mm height, is resting on HP on its base, whose one side is perpendicular to vertical plane. Now second line. Here it is given that it is cut by a cutting plane, makes an angle of 45 degree with HP. So we have to draw a cutting plane such that which makes an angle of 45 degree with XY line in front view, and it passes through the midpoint of the axis. Hence we have to find out the midpoint of the axis of this solid. So for that, mark a point at a distance of 25 mm from XY line on the axis of given pyramid, somewhere here. So this is the point through which a cutting plane line would pass. So from this point, draw a line at an angle of 45 degree like this. So this is a cutting plane line, and this portion is cut by this cutting plane line. The angle is given as 45 degree. So we have drawn the second line. Now we have to worry about the sectional top view and true shape. To draw the sectional top view, we find out the point of intersection between the cutting plane and the slant edges. Here cutting plane is this and the slant edge is O dash A dash. So find out the point of intersection, that is point on O dash A dash and point on this cutting plane. So this is the point. So from that point draw a vertical line and that will cut OA at one point and OB at another point. So 2 points are here. Here also 2 points are there and both the points are at the same venue, same position in this front view, and in top view both are different. Both are on OA and OB slant edges. Now find out position of these 2 points. Here also 2 points are there. One point is on OE, another point is on OC. So from that draw a vertical line and that vertical line would cut OA, OE and OC at 2 points like this. One point is here and another point is here and another point is somewhere here. Intersection of this cutting plane and O dash D dash. So this is the point. So from that point draw a vertical line and that vertical line will cut OD at one point. So that is this point. Now join all these 5 points with a straight line like this. These 5 points with a straight line because no any curvature shape is there. It's a pyramid, it's not cone. So here all the straight lines would be there, and then erase this internal portion like this because this portion would not is cut out, it's trimmed portion, and name these points point number 1, 2, this is point number 3, 4 and 5. 5 end points of the given cut portion. So this view represents the cut portion, top view of the cut portion of given pentagonal pyramid. If we cut this pentagonal pyramid somewhere here, its top view would appear like this, and this portion is cut away. Hence we draw section lines like this, which makes an angle of 45 degree with XY line. So draw a section lines like this. All these lines should be equidistant and they should make an angle of 45 degree with XY line. It can be drawn in any direction. And this is the sectional top view of given problem. So we have finished sectional top view. Now we worry about true shape over here. And this is a front view of given problem. So we have drawn 2 views, front view and sectional top view. In many cases, students forget to write the names of views. So that will reduce the marks. Hence it is compulsory to write the names of views below the figure. Suppose this is front view, this is sectional top view. Of course, here you should write sectional top view, not only top view, because here sectional portion is there. Now we worry about its true shape, and for that let we identify the 5 points on this line. 1 dash, 2 days are over here. Here 2 points are there, 3 days. Here point number 4 days is there, and here 5 days is there. So 5 points are there on this cutting point line. 1 days, 2 days, 3 days, 5 days and 4 days. Now from all these points draw a line perpendicular to the cutting plane line like this. This drawn line is perpendicular to this cutting plane line, and this distance is equal to the distance of point 1 from XY line. So this distance and this distance both are same. So mark this point. Similarly, mark another point over here, that is distance between point number 2 and XY line and 2 days and this point. Both the distances are same. So with the help of compass we can measure the distance from this point to this point, that is distance of point number 2 from XY line. Take this distance on your compass, put it over here on point 2 days, cut arc over here, and that will cut this vertical line or the line drawn from this cutting plane line at a right angle over here. So this is another point. Similarly, we have to find out point number 3 and 5 on this. So for that, from here, from 3 days and 5 days, draw lines at an angle of 90 degree to this inclined line and mark 2 points, point number 5 and point number 3. Measure distance of XY, distance between point number 5 and XY line, and point number 3 and XY line, put these 2 points over here. Similarly, find out position of point number 4. So for that, from point number 4, draw a line which makes an angle of 90 degree with this cutting line, and measure the distance of between XY line and point number 5 and cut it over here, somewhere here. So these are the 5 points, and join all these 5 points with a straight line, and this represents the true shape of given solid, given section. And draw section lines like this. So whenever you draw section lines in a true shape or any cutting plane reference shape, so for that you should take care about one thing. The angle between this cutting plane line or this section line and the reference line should be 45 degree. As this line is making an angle of 45 degree, so 45 plus 45, cumulative angle would be 90 degree. So here this angle may be either 90 degree or it would be horizontal or 0 degree. Here this line should not be drawn 45 degree like this. Mind well, here this angle between this line and this line, reference line, should be 45 degree. So either it would be vertical or it would be horizontal. And name this view as it's a true shape of the section. So this question carries 7 marks, 2 marks for sectional top view, 2 marks for front view, 2 marks for true shape, and 1 mark for the section lines, dimensioning and naming the points. So this is the final solution of given problem. Now we proceed further with some more example. Question number 3b. In question number 3b, asked for 7 marks, it is asked that draw the development of lateral surfaces of a given hexagonal prism having sides 25 mm as shown in figure. The figure is given like this. Dimension is not written in this figure, but it is given that 20 mm is the size of the given hexagonal solid. So how to cut this, and after cutting this, from any edge, what should be its developed portion, that we have to draw over here. Let me draw it over here. So for that, first we draw a hexagon of given dimension, that is 20 mm side length, it is given to us. So we draw a hexagon. We know how to draw hexagon of 20 mm side length. So for that, let me take distance of 20 mm on our compass, draw a circle of dimension 20 mm like this, draw a circle. After drawing this circle, draw section lines, draw vertical center line and horizontal center line like this. As we have to draw hexagonal prism like this, such that 2 sides parallel to XY line. So for that, we cut over here. Intersection of this horizontal center line and circle would be 1 point. Cut arc over here, 1 arc over here, another arc over here. Similarly, put up this point over here, draw arc on this side, arc on this side, and join all these 6 points with the straight lines like this. So this straight line would represent the edges of given solid. They should be joined like this. A hexagon of side length 20 mm. This hexagon is not given, just 2 lines are drawn over here. These 2 lines, both the lines are full line, so we have to assume that hexagon would lying like this, such that 2 sides parallel to XY line. It may be in other position, such that 2 sides may be perpendicular to XY line. In that case, here these 2 lines would not appear. Instead of these 2 lines, 1 line would be there at the middle. But here 2 lines are shown, means the 2 sides are perpendicular, parallel to XY line, and draw its axis like this. Axis of this solid. It's compulsory to draw axis in every problem. Then insert appropriate dimension, hexagonal 20, height 60, this angle is 45 degree, and the value of this radius is not mentioned. of course it would be the distance, this distance, that is 20 mm. Now a hexagonal prism is developed. So development of this hexagonal prism would be 6 rectangles. So for that, draw a rectangle, draw 6 rectangles of dimension 20 mm. So 20 plus 20 plus 20 plus 20, so total 120 mm would be the total width of the developed portion of this pentagonal hexagonal prism. Hence we have to draw rectangle like this. The height of this developed portion would be equal to height of this front view, that is 60 mm. So from here, draw a rectangle like this. Width is equal to 120 mm. So it would appear like this. Arrows, and dimension is 120 mm. That is 20 into 6. If it is a pentagonal prism, it would be 5 into 20. So this rectangle is the development of given solid if it is not cut anywhere. If the prism is not cut anywhere, then its development would be just a rectangle like this. And here draw vertical lines at a distance of 20 mm each to represent that the all 6 rectangular faces of the solid like this. Draw vertical lines. Now we name the points. We start from here. This is point A in top view. This is point B, point C, D, point E, and point F. 5 points are there, and from all these points vertical lines are drawn over here. So here is point A dash, B dash, and here point C dash, D dash, E dash, F dash, and so on. Here is point F dash. Now here, suppose we assume that we have cut this solid from point A. So this is first edge, and here is point A. Edge A is here is B, here is C, D, E, F, and back to A. So this portion A, B, C, D, E, F, and back to A represent these faces.